Welcome to the session on median. Myself Josmi Joseph, Assistant Professor of Computer Science. One of the important objectives of statistical analysis is to get a single value that describes the characteristics of the entire data. As the average or the measure of central tendency lies in between the largest and smallest value of the series, it is called the central value. They give us an idea about the concentration of values in the central part of the distribution. The main or the commonly used measures of central tendency are mean, median and mode. In previous sessions we have already seen this arithmetic mean and the way in which it is calculated. Now we are going to see median, and mode will be discussed in the coming sessions. Median is a positional average and its value depends upon the position occupied by a value in the frequency distribution. According to L.R. Connor, the median is that value of the variable which divides the group in two equal parts, one part comprising all the values greater than and the other all the values less than the median. Now we can see how to calculate the median for ungrouped data and for the group data. For group data we have two representations, discrete frequency distribution and continuous frequency distribution. First let us see calculation of median for ungrouped data or individual series. Here you will be given with data values or the observations. First arrange those observations in ascending or descending order of the magnitude. Now if the number of observations is odd, median is the middle value of the observation. And if the number of observations is even, the median is the arithmetic mean of the two middle observations. This can be generalized as if there are n observations in the series and all the observations are expressed in ascending or descending order of the magnitude, then if n is odd, median is equal to n plus 1 by 2th term, and if n is even, median is arithmetic mean of n by 2th and n by 2 plus 1th term. That means median is equal to n by 2th term plus n by 2 plus 1th term divided by 2. Find the median of 5 observations 35, 12, 48 and 60. First arrange all these values in the ascending order. We will get 8, 12, 35, 40 and 60. Now we have only 5 observations, so the middle value is 35, so the median is 35. And now suppose if I replace the value 8 and 12 by 0 and 3, it won't affect the median. Median will be 35 itself. And suppose if 40 and 60 I am replacing with 90 and 500. Then the series is 8, 12, 35, 90 and 500. Then also median is 35. That means the extreme observations doesn't affect the median. Another example, find the median of 6 observations 35, 12, 40, 8, 50 and 60. First arrange these elements in the ascending order. We will get 8, 12, 35, 40, 50 and 60. So median is equal to arithmetic mean of these two middle terms. These are the two middle terms. So arithmetic mean of these two means 35 plus 40 divided by 2, which is 37.5. For discrete frequency distribution. In case of frequency distribution where the variables take the values x1, x2, x3, etc., xn with the respective frequencies f1, f2, f3, etc., fn. Here the total frequency is f1 plus f2 plus etc. plus fn, which is n. Now the median is n plus 1 by 2th term or observation. So how to find this n plus 1 by 2th term is, first you prepare a cumulative frequency, less than cumulative frequency distribution, and from that we can find which is the element at the position n plus 1 by 2th position. Here the steps are: prepare the less than cumulative frequency distribution table and find n by 2 and find the cumulative frequency just greater than n by 2. The corresponding value of the observation gives the median. See here an example. 8 coins were tossed together and the number of heads resulting was noted as the x. And the operation was repeated 256 times and the frequency distribution of the number of heads is given below. So here x values are 0, 1, 2, 3 up to 8 and the frequency values are given here. So from this calculate the median. First prepare a table like this where the given x values are written here and the frequencies are also listed. Here the total frequency is n is equal to sigma f is equal to 256. The less than cumulative frequency is calculated as the number of values less than or equal to 0, that is only 1. So we have this cumulative frequency 1 here. Next, for the value 1, the number of values which is less than or equal to 1, that means the number of values which is equal to 1 is 9 and less than means 1. So 9 plus 1, 10. So then the number of values which are having the values less than or equal to 2 and less than that. So 26 plus, these are the values less than or equal to 1. So 26 plus 10, 36. Now for 3, the cumulative frequency is 59 plus 36, 95. For 4, cumulative frequency is 72 plus 95, 167. And for 5, cumulative frequency is 52 plus 167 is equal to 219. 52 plus 167 is equal to 219. And for value 6, less than cumulative frequency is 29 plus 219 gives 248. And for 7 plus 248, 255. And for 8, 1 plus 255, which is 256. This is how we can calculate less than cumulative frequency. Now from this we need to calculate what is the value of n by 2. So here n is 256. So 256 by 2 is 128. Now find the cumulative frequency which is just greater than 128, just greater than n by 2. So here it is 1 less than 128, 10 less than 128, 36 less than 128, 95 less than 128. So when 167 is greater than 128. So this is the frequency, cumulative less than cumulative frequency we are taking. So corresponding to this, the x value is 4. So that is the median for this frequency distribution. So first find the n by 2 and identify the cumulative frequency just greater than this n by 2, and x value corresponding to that is the median for this set. Here we have seen the median as a measure of central tendency and how to calculate the median for ungrouped data. In case if we have odd number of elements, middle element is the median after arranging the elements in the ascending order. And in case of even number of elements, after arranging the elements in the ascending order, the two middle elements, take the average of those two, we will get the median. For discrete frequency distribution, prepare the less than cumulative frequency table and from that find the cumulative frequency just greater than n by 2 and the x value corresponding to that cumulative frequency value is the median. So, for continuous frequency distribution, the calculation of median will be discussed in the coming session. Thank you.